Hello friends, today we are going to solve previous year's questions from NEET of Chemistry Chapter 1, some basic concepts of chemistry. Question 1, the maximum number of molecules is present in 15 liter of H2 gas at HTP, 5 liter of N2 gas at HTP, 0.5 gram of H2 gas or 10 gram of O2 gas. We know that moles is equal to volume by 22.4. Also moles is equal to number of particles by Avogadro number. Therefore, number of particles is equal to volume by 22.4 into Na. 15 liter of H2 gas at HTP contains 4.03 into 10 power 23. 5 liter of N2 gas at HTP contains 1.34 into 10 power 23 molecules, and 0.5 gram of H2 gas contains 1.5 into 10 power 23 molecules, and 10 gram of O2 gas contains 1.88 into 10 power 23 molecules. So the maximum number is present in A. Question 2. The mole fraction of the solute in 1 mole aqueous solution is 1 mole of solute is present in 1 kg of H2O as given in the question. 1 mole of solute is present in 1000 by 18 mole of H2O, because mole is equal to mass by molar mass. So therefore mole fraction of solute is equal to moles of solute by moles of solvent plus moles of solute, which is equal to 1 by 1000 by 18 plus 1, which is equal to 18 by 1018. So therefore mole fraction is equal to 0.01768, approximately equal to 0.018, which is option B. Question 3. The concentrated aqueous sulfuric acid is 98% H2SO4 by mass and has a density of 1.8 gram per milliliter. Volume of acid required to make 1 liter of 0.1 molar H2SO4 solution is, as I have given, mass of H2SO4 is equal to 98 gram, mass of solution is equal to 100 gram, volume of solution is equal to mass by density, which gives 55.55 ml or 0.0555 liter. Molarity of solution is equal to moles by volume, and moles is equal to 98 given mass divided by molar mass, which is also 98, which gives molarity M1 is equal to 18.02 molar. Let V1 ml of H2SO4 be required to prepare 1 liter of 0.1 molar H2SO4. We know that M1 V1 is equal to M2 V2. So therefore 18.02 into V1 is equal to 0.1 into 1000 ml. Therefore V1 is equal to 100 by 18.02, which gives 5.55 ml. So therefore it is option C. Question 4. An element X has the following isotopic composition: 200X, which is 90%, 199X, 8%, 202X, 2%. The weighted average atomic mass of the naturally occurring element X is closest to. We know that average atomic mass is equal to A1X1 plus A2X2 plus A3X3 and so on, divided by X1 plus X2 plus X3 and so on, where A average is equal to average atomic mass. A1, A2 and A3 are isotopic mass of elements. X1, X2, X3 are natural abundance of isotopes. So therefore average atomic mass is equal to 200 into 90 plus 199 into 8 plus 202 into 2 divided by 90 plus 8 plus 2, which gives 199.96 AMU, which is approximately equal to 200 AMU. It is option D. Question 5. What volume of oxygen gas measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of propane gas C3H8 measured under the same conditions? So we have the equation: C3H8 plus 5O2 gives rise to 3CO2 plus 4H2O. According to equation, 1 volume or 1 liter of propane gas requires 5 volume or 5 liter of O2 to burn completely. So therefore it is option A. Question 6. How many moles of lead 2 chloride will be formed from a reaction between 6.5 gram of PbO and 3.2 gram HCl? We have the equation: PbO plus 2 HCl gives rise to PbCl2 plus H2O. Molar mass of PbO is equal to 223. Therefore 6.5 gram of PbO has 0.029 moles. Molar mass of HCl is equal to 36.5. Therefore 3.2 gram of HCl has 0.0876 mole. Also 1 mole of PbO reacts with 2 mole of HCl according to the equation. Therefore PbO is limiting reagent. 1 mole of PbO gives 1 mole of PbCl2. Therefore, 0.029 mole of PbO gives 0.029 mole of PbCl2. Therefore, it is option B. Seventh, volume occupied by one molecule of water of density 1 gram per centimeter cube is. We know weight of 6.023 into 10 power 23 molecules of water is 18 gram. Weight of 1 mole of molecules of water. Therefore, volume occupied by Na molecules of water of density 1 gram per centimeter cube will be 18 divided by 1 gram per centimeter cube, which is equal to 18 centimeter cube volume. Therefore, volume occupied by one molecule of water is equal to 18 divided by 6.023 in 10 power 23, which is equal to 2.988 in 10 power minus 23, approximately equal to 3 into 10 power minus 23 centimeter cube. So therefore, it is option A. Question 8. 10 gram of hydrogen and 6.64 gram of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be. We know that H2 plus half O2 gives rise to H2O. Here are 2 grams of H2, 16 grams of O2 and 18 gram of H2O, which means 1 mole of H2 and 0.5 mole of O2 and 1 mole of H2O. 10 gram of H2O is equal to 5 mole and 64 gram of O2 is equal to 2 mole. Oxygen is the limiting reagent, so amount of H2O produced depends on O2. 0.5 mole of O2 gives 1 mole of H2O, and therefore 2 mole of O2 gives 4 mole of H2O. So the correct option is B. Question 9. The number of atoms in 0.1 mole of a triatomic gas is. We know that number of atoms is equal to Na into number of moles into 3, because it is a triatomic gas. So therefore 6.02 into 10 power 23 into 0.1 into 3, which is equal to 1.806 into 10 power 23. It is option B. Question 10. Which has the maximum number of molecules among the following? 44 gram CO2, 48 gram O3, 8 gram H2 or 64 gram SO2. So 44 gram CO2 contains 1 mole, which means Na number of molecules. O3 contains Na number of molecules. H2 contains 4 Na number of molecules, and SO2 contains Na number of molecules. So the maximum number of molecules is present in C. Question 11. 6.02 into 10 power 20 molecules of urea are present in 100 ml of its solution. The concentration of the solution is. So moles of urea is equal to given number of particles by Avogadro number, which gives 10 power minus 3. Concentration molarity is equal to moles by volume in liter, which is equal to 10 power minus 3 divided by 100 into 10 power minus 3 liter. Molarity is equal to 1 by 100 is equal to 0.01 molar. So it is option D. Question 12. In an experiment, it showed that 10 ml of 0.05 molar solution of chloride required 10 ml of 0.1 molar solution of AgNO3. Which of the following will be the formula of chloride? X stands for the symbol of the element other than chlorine. 12th. Millimoles of solution of chloride is equal to 0.05 into 10 is equal to 0.5. Millimoles of AgNO3 solution is equal to 10 into 0.1 is equal to 1. Therefore, millimoles of AgNO3 are double than the chloride solution. Also, XCl2 plus 2AgNO3 gives rise to 2AgCl plus XNO3 twice. Therefore, it should be option B, XCl2. Question 13. Equal masses of H2, O2 and methane have been taken in a container of volume V at temperature 27 degrees Celsius in identical conditions. The ratio of volumes of gases H2, O2, methane would be. According to Avogadro's hypothesis, ratio of volumes of gases will be equal to the ratio of their number of moles. And also number of moles is equal to mass by molar mass. Let mass of X2, O2 and methane be X, which is equal. Therefore, given mass by molar mass, X divided by 2, molar mass of H2, and X divided by 32, molar mass of O2, and X divided by 16, molar mass of methane. So therefore, we get 16:1:2. It is option C. Question 14. When 22.4 liters of H2 gas is mixed with 11.2 liters of Cl2, each at STP, the moles of HCl formed is equal to. Moles of H2 is equal to given volume by 22.4 is equal to 1 mole. Moles of Cl2 is equal to given volume by 22.4 is equal to 0.5 mole. We also know H2 plus Cl2 gives rise to 2HCl, where chlorine is limiting reagent here because we have taken it in lesser quantity. Therefore, 1 mole of HCl is formed. Option A. 15. 1 gram of magnesium is burnt with 0.56 gram of O2 in a closed vessel. Which reactant is left in excess and how much? Atomic weight of magnesium is 24 and oxygen is 16. 15. We know 2 Mg plus O2 gives rise to 2 MgO. A 48 gram Mg reacts with 32 gram of oxygen. Therefore, oxygen is the limiting reagent. So, X gram of Mg reacts with 0.56 gram of O2, which gives X is equal to 48 into 0.56 divided by 32 if we cross multiply. Therefore, X is equal to 0.84 magnesium used. Excess of magnesium left is equal to 1 minus 0.84 is equal to 0.16 gram of magnesium. So therefore, it is option A. 16. A mixture of gases contains H2 and O2 gases in the ratio of 1:4 weight by weight. What is the molar ratio of the two gases in the mixture? 16. Moles of H2 is equal to 1 by 2 because given mass by molar mass. Moles of O2 is equal to 4 by 32. Molar ratio 1 by 2 is to 4 by 32, which gives 4 is to 1. It is option D. 17. What is the mass of the precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% NaCl solution? Question 17. 16.9% solution of AgNO3 means 16.9 gram of AgNO3 in 100 ml of solution. 16.9 gram of AgNO3 in 100 ml solution is equal to 8.45 gram of AgNO3 in 50 ml solution. Similarly, 5.8% of NaCl in 100 ml of solution is equal to 2.9 gram of NaCl in 50 ml of solution. We have the equation AgNO3 plus NaCl gives rise to AgCl plus NaNO3. Moles of AgNO3 is equal to, given mass is 8.45 divided by 170, which is the molar mass of AgNO3, is equal to 0.049. Moles of NaCl is equal to 2.9 divided by 58.5, given mass by molar mass, which is equal to 0.049. Also, 1 mole of AgNO3 and NaCl give 1 mole of AgCl. Therefore, 0.04 mole of AgNO3 and NaCl will give 0.049 mole of AgCl. We all know moles is equal to given mass by molar mass. Given mass of AgCl we have to find, and molar mass of AgCl is 143.3. Therefore, mass of AgCl is equal to 7.02, which is approximately equal to 7 gram. It is option B. 18. If Avogadro number Na is changed from 6.022 into 10 power 23 per mole to 6.022 into 10 power 20 per mole, this would change. Option A, the mass of 1 mole of carbon. Option B, the ratio of chemical species to each other in a compound. Option C, the ratio of elements to each other in a compound. Or option D, the definition of mass in units of grams. So, mass of 1 mole of carbon, 6.022 into 10 power 23 atoms is equal to 12 gram. If Avogadro number is changed to 6.022 into 10 power 20, then mass of 1 mole of carbon is equal to 12 into 6.022 into 10 power 20 divided by 6.022 into 10 power 23, which is equal to 12 into 10 power minus 3 gram. So therefore, the mass of 1 mole of carbon will be changed. Option A. 19. The number of water molecules is maximum in. Option A. 1.8 gram of water contains 6.023 into 10 power 22 molecules. Option B. 18 gram of water contains 6.023 into 10 power 23 molecules. And 18 moles of water contains 18 into 6.023 into 10 power 23 molecules. So it is option C. 20. Suppose the elements X and Y combine to form two compounds XY2 and X3Y2 when 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram. The atomic weights of X and Y are. Let the atomic weights of X is X, small x, and that of Y is small y. And the first compound XY2, where moles is equal to given mass by molar mass. Let the molar mass be M1, 10 divided by M1, which gives M1 is equal to 100. X plus 2y is equal to 100 because molar mass is equal to mass of X in that compound plus 2 into y is equal to 100, equation 1. Here X3Y2 in this compound, N2 is equal to 9 gram divided by M2, where M2 is the molar mass of that compound. M2 is equal to 180. Therefore 3x plus 2y is equal to 180. Equation 2, solving 1 and 2, we get x is equal to 40 and y is equal to 30. Therefore it is option A. A mixture of 2.3 gram of formic acid and 4.5 gram oxalic acid is treated with concentrated H2SO4. The evolved gaseous mixture is passed through KOH pellets. Weight in gram of the remaining product at STP will be. Formic acid HCOOH is treated with concentrated H2SO4, which is a dehydrating agent, gives rise to CO plus H2O. Also, N1 moles is equal to given mass by molar mass. Given mass is 2.3 divided by 46 is the molar mass, which gives 1 by 20. 1 mole of formic acid gives 1 mole of CO. Therefore, 1 by 20 mole of formic acid gives 1 by 20 mole of CO, carbon monoxide. And H2C2O4, oxalic acid is treated with concentrated H2SO4, which gives rise to CO plus CO2 plus H2O. Moles of oxalic acid is equal to given mass 4.5 by molar mass 90 is equal to 1 by 20. 1 mole of oxalic acid gives 1 mole of CO and CO2. Therefore, 1 by 20 mole of oxalic acid gives 1 by 20 mole of CO and O2. H2O is absorbed by H2SO4. Gaseous mixture containing carbon monoxide and carbon dioxide, when passed through KOH pellets, CO2 gets absorbed. So therefore, moles of carbon monoxide left unabsorbed is equal to 1 by 20 plus 1 by 20, which is equal to 1 by 10. Mass of carbon monoxide is equal to moles into molar mass. 1 by 10 into 28 molar mass of carbon monoxide gives 2.8 gram. So therefore, CO is left unabsorbed, 2.8 gram. In which case is the number of molecules of water maximum? A, 18 ml of water. B, 0.18 gram of water. C, 0.00224 liter of water vapors at 1 atm and 273 Kelvin. Or D, 10 power minus 3 mole of water. So A, 18 ml of water. N is equal to moles into Na, number of particles, number of molecules. Mass of water is equal to volume into density is equal to 18 into 1, which is density of water is 1 gram per centimeter cube. So therefore, mass of water is 18 gram. And number of particles is equal to 18 divided by molar mass 18 into Na is equal to Na. So therefore, number of molecules is equal to 6.022 into 10 to the power 23. Option B, 0.18 gram of water. Moles is number of particles is equal to moles into Na. Moles is equal to 0.18 divided by 18. Therefore, number of particles is 10 power minus 2 Na. C, 0.00224 liter of water vapors. N is equal to moles into Na. Moles is equal to given volume by 22.4. So therefore, the number of particles is 10 power minus 4 Na. D, N is equal to moles into Na, where moles is 10 power minus 3, it is given. So therefore, number of particles is 10 power minus 3 Na. Therefore, the maximum number of particles, molecules of water is present in option A. 23. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process is, Haber's process, according to Haber's process, N2 plus 3H2 gives rise to 2NH3. Therefore, 2 moles of NH3 are found by 3 moles of H2O. Therefore, 20 moles of NH3 will be found by 30 moles of H2. It is option D. 24. Which one of the following has maximum number of atoms? Option A, 1 gram of O2 contains number of particles is equal to moles into Na. N is equal to 1 by 32 Na. Option B, 1 gram of Li solid. N is equal to 1 by 7. It is molar mass of Li is 7 into Na. Option C, 1 gram of Ag. N is equal to 1 by 108 into Na, where 108 is molar mass of Ag. D, 1 gram of Mg. N is equal to 1 by 24 into Na, where 24 is molar mass of magnesium. So the maximum number of particles is contained by 1 gram of helium. So thank you. Like, subscribe and share the video.